Legends of Light and Nabobs of NeoPixels, it's Professor Gallaugher, and in this lesson, we'll learn to attach a NeoPixel light strip to a CircuitPlayground. The same code and techniques will work for the Bluefruit or Express. We'll learn to access the light strip through our CircuitPython code, and we'll adapt some of our code that worked with the onboard NeoPixels so that it will now also work with an attached NeoPixel light strip. Let's hook up to some big learning. Now, if you're new here, you might want to start out with the earlier lessons in the playlist, and if you don't have a NeoPixel strip, you can feel free to skip to the later videos, but all of my students have one of these types of NeoPixel strips. Now, some might be longer with more space in between the lights, but each strip has 30 lights on it. If you add a lot more lights, you'll probably need a separate power source. Now, as mentioned in an earlier lesson, NeoPixel is Adafruit's brand name for a type of RGB light that is individually controllable. Now, there are lights that aren't branded as NeoPixels, but that also work with the same wiring and programming scheme that we're going to demonstrate. These lights usually say they're NeoPixel compatible, and they may adhere to a standard like the ones that you see on screen. I usually buy stuff from Adafruit when I can. They take a lot of time to choose high-quality vendors to work with, and you can count on their technical support. You won't get that if you use third-party products. But if you search the Adafruit website for NeoPixels, you'll see all sorts of options. Adafruit refers to lights that have the rigid belt-like backing that we're using as NeoPixel strips, and lights that have a flexible wire between them as NeoPixel strands. Again, writing and coding is identical for both strips and strands. You'll also find NeoPixels in rectangular displays, smaller displays. There are circular sets of NeoPixels, NeoPixel glasses, keycaps with NeoPixels in them, individual lights, and as mentioned, you could use compatible third-party lights as well. In the Disco Button project later in the playlist, I'm using third-party lights that work just like NeoPixels, but they're smaller and there are a lot more on a single strand. Now, when you're ready to learn more about NeoPixels, you can check out Adafruit's NeoPixel Uber Guide. Now, the standard RGB NeoPixel strips and strands that we're using have 3 wires with alligator clips attached to each end. The red wire is power, the black wire is ground, and the white wire is the data wire that's used to control our lights. The colors won't always be the same on your strip, but standard RGB NeoPixels will have 3 wires, 1 power, 1 ground, and 1 signal. Now, this is how we attach the strip to our CircuitPlayground board. First, make sure the board is unplugged. You probably won't run into a problem if you plug and unplug the strip with the board powered up, but sometimes you can cause a short, and in the most extreme cases, you can wipe out files on your board and you'll have to do a reinstall. Now, in this NeoPixel strip, our power is going to go to the V-out pad. The lights will work if you attach power to either of the 3.3 volt pads as well, but V-out will take advantage of the full power you get when you plug your board into a USB or battery. NeoPixels can handle a higher power, so we're going to use V-out. Ground can go into any of the ground pads. There are 3 on this board. And for signal, on this strip, that's the white wire. Where we clip the signal wire is going to be associated with the code that we write. And we're going to write code assuming that it's clipped to the A1 pad, so let's clip it there. Now, when I plug my CircuitPlayground in, I see some flashing because I've already written some code to use the LED strip. You're running the last code that you wrote, so you're likely not seeing anything light up the strip yet, but let's change that. So let's plug your board in with NeoPixel light strand attached and launch PyCharm. Now, I'm going to start by working on a file that we wrote in an earlier lesson, lightsoutandback.py, and I've chosen this simply because it's got some setup code for us. I won't need this while true loop, so I'm going to delete that. And if you don't have this code, you can pause and type the code in that you see here. Now I'm going to rename the comment flashing-a-neopixel-strip.py, and now let's look at how we set up onboard NeoPixels. A reminder. Pixels is the name of the object that we create with the NeoPixel class. That class is capital N, capital P, and we imported that from the NeoPixel library, all lowercase. You see this guy right here. We got that from the import statement up here. And when we follow a class with parentheses, we mean go to the class factory and make an object using that class. And in this case, we're going to the capital N, capital P NeoPixel class, and that requires 2 inputs to create a NeoPixel object. The first is the location of the NeoPixel lights that we want to control with that object. That's board dot and in all caps NeoPixel. That means the NeoPixel objects that are built into the board. Not all boards have them, but CircuitPlaygrounds do. And the 10 is the number of NeoPixel lights at this location. And remember, once we create a pixels object, it has built-in functions that we call methods, and it also has a bunch of variables that we can use and control. And when we use those methods or variables with pixels, we apply them to the lights on the board. Let's use the .fill method right now. So we'll write a while true loop, and we'll say while space capital T true colon, then underneath this indented we'll say pixels.fill passing in red, time.sleep passing in time interval, pixels.fill white, time.sleep passing in time interval, pixels.fill blue, time.sleep passing in time interval. So the .fill is a method of the NeoPixel class, and by saying pixels.fill, we're saying fill in all of those pixels that are on our board. Let's open the terminal, make sure you're in TO, save, and we see some very patriotic flashing, if you're an American, or you have an RWB flag. But we want the light strip to flash too. Well, what we need to do is to create a second object that points to the light strip. And we'll use the same techniques we used for the pixel object that points to the neopixels that are on the board. We're going to start with a variable to hold the object. Now we could name this anything, but since we want to keep track of the light strip, let's call it strip, all lowercase. And as I add the voiceover for the code, I should have listed this comment as set up our 30 neopixels attached to pad A1 and call them strip. And we'll set this equal to, and we're creating a NeoPixel object, capital N, capital P. So we first refer to the NeoPixel library, all lowercase NeoPixel, and then say dot, and then say NeoPixel, capital N, capital P. That gets the NeoPixel class in the NeoPixel library. And then between parentheses, we pass in two values to create that NeoPixel object. The first is the location of the lights. And remember, we clipped our light strip signal wire, the white wire, to pad A1. So we'll just say board dot A1 in this case. So board.neopixel refers to the neopixels on the board. Board.A1 refers to a neopixel strip where the lights are connected to pad A1. Then we need to follow this with the number of neopixels at that location. I'm going to say comma 30 because I've got 30 lights on the strip. And that, my friends, is it. And you probably know how we can make our light strip flash. Since strip is an object of type neopixel, it too has a .fill method. So down here in while true, we'll follow pixels.fill with strip. See, code completion knows about strip. And then .fill, because again, code completion knows that strip is a neopixel object, capital N, capital P, which should have access to that fill method. And then we'll just pass in the same colors. Red first, then I'll copy this whole line, paste it below white and change the color to white, and then paste it below blue and change the color to blue, and then we'll open the terminal back up and save, and behold the flashy awesomeness. The light strip is flashing red, white, and blue, along with the onboard neopixels. Why don't we slow down the flash? How about changing the time underscore interval to 0.3, and we'll save again. And that waits 3 times as long between flashes. It's a little less garish. So excellent! Luminous coder, you now know how to attach and use NeoPixel light strips with a CircuitPlayground, Express or Bluefruit. So let's save this to the CircuitPython School folder as flashing a NeoPixel strip, and make sure you close your outermost tab and get back to code.py. And now that you know how to work with NeoPixel strips, let's issue some challenges. So first, modify the code that you wrote for the lights out and back challenge. Remember that guy? Now change it. First, clip a NeoPixel strip to your CircuitPlayground with signal pin attached to A1 and refer to the light strip in your code as strip, just as we've been doing. And then beginning with the first light in the strip, light 0, light it in green, then wait 0.1 seconds, then light the next light in orange and also wait 0.1 seconds, alternating until all the lights in the light strip are on. Then turn off each light in the light strip, starting with light 29 through light 0, waiting 0.1 seconds after turning each light off, and repeat forever. Save this as strip lights out and back.py. Correctly completed code should look like the video that you're seeing at the right. So why don't you give this a shot, pause, and when you're ready, resume. Now, I'm not going to show the answer to these two solutions for my students. We'll cover the solutions briefly in our second class together, but you've got to submit your solutions online. But if you're not in my class and working with another instructor, you can rely on them to correct your work and show a solution later. And if you're working on your own and playing the home game, well, homie, I am confident that you can crack the solution on your own. Until we meet again, continue to hack.